Alright, welcome to the box and whisker plot video. Yes, this is going to be exciting. And what's another name for box and whisker plots? The name that I prefer, box plots, and later on in this video we'll talk about what a modified box plot is. But at first we're just going to talk about the basics. So, a box and whisker plot, or aka box plots, what are they? Convenient way to display the 5-number summary. That's right, folks, the 5-number summary from the last video. We're going to talk about how to take that set of values and use that to construct a nice, pretty picture. First and foremost, what are you going to want to do? You're going to want to go get yourself some quantitative data. Remember, we're always talking about quantitative data. Data that has units. And we're going to learn to tell a story with a picture of a set of data. First, we're going to very generically go through the how to take that 5-number summary and construct a box plot. Be sure to write along with me. That includes all sentences. Yes, that's right, kids. Write everything in your notes, including the sentences, not just the math mumbo-jumbo. All right, so here we go. How do we construct a box plot? Well, the first thing you're going to need is to mark your minimum, maximum, median, Q1, Q3, yada, yada, yada. This is your 5-number summary. So over here, what I've done is I've created just a fake 5-number summary for us to work with. So what does it mean to mark the minimum? I mean, literally, go in here and we take our minimum, and I'm just going to put a little mark. That's going to be my minimum. Q1 is about 25, and I'm going to continue on. So go ahead, press pause, and copy a number line like this, and mark all of the remaining pieces. Okay, now you may want to press pause and get part B. Now we're going to draw the box that represents the middle 50%. The middle 50% goes from Q1 to Q3. So if we label our little hashtags here that we made marks across, I'm going to go ahead and press pause myself. I'm going to label those up. Okay, so I have all of my labels right here. So what I'm going to do is the box of the box plot goes from Q1 to Q3. So all I'm going to do is just construct the box. Here's my Q1, here's my Q3, and I'm just going to build a box. And then the length of the box now represents this interquartile range. Inter, within the quartiles, right, and the range, the distance between Q1 to Q3. That distance, as you see over here from Q1 to Q3, is 60 minus 25. I do the big number, Q3 minus Q1. Or just 35 units. So if somebody said, you know, what is the interquartile range, you would say 35 units. Now, the next piece is just taking our median and drawing that line in the box. So now we know that this piece right here represents 35 units, and 35 is the halfway mark if we list our data in order from least to greatest. 35 is that central value. Now that we've accomplished that, right, we've drawn our vertical line segment in the box to show the median. Next, we're going to draw the whiskers to represent the lowest 25% by connecting Q1 to the minimum value. So here's my Q1 going all the way down to my minimum value. And then the highest 25% by connecting Q3 to the maximum value. So I go from Q3 to the maximum, and there you have it, Viola, right? Our box plot, or box and whisker plot. And a lot of times you'll see sample ones. I'm going to show a quick one down here. You'll see a lot of sample ones drawn like this. Now, if the data is perfectly symmetrical and the world is perfect, then yeah, you might get something that looks like this box plot here. But I like the one that I chose to draw. Obviously, I chose to draw it because it shows that there's a little bit longer of a whisker on the left than on the right, and that the median isn't in the dead center of the box, it's off to the side. All of this indicates a little bit of skewness that you also identified and saw in your histograms. Let's move on. This slide has a nice little formal picture drawn for you right here, and all of the steps right here, which we just talked about. So if you don't have them all nice in order, now's a good time to press pause and copy this page into your notes. Okay, now that you have your solid notes, let's move on to some real data. Over here on the right side here, it says that the data on the right lists the high, average, and low temperatures in Farmington, Connecticut from September 8th to September 23rd. Complete the table using your calculator, right? And the suggestion is to put the data in L1 and L2 and L3, such as this. Now, you don't have to put high temperature in L1 and average in L2 and low in L3, but I think this would be a good idea. If you're at home, you can easily take all of this data here and do it by hand. What I'm going to do is I'm going to work through this for the high temperatures for you on the video, and then for class, you're going to wrap up the average and low. So the first thing I'm going to do is I'm going to press pause myself. I'm going to put high in L1. I'm going to calculate my one variable stats as noted in the previous video to this, the 5-number summary video. We'll go through that if you need help. Go back to that one. Process my 5-number summary, and then I'm going to list them out right here. Go ahead, press pause, and you work on that now. Okay, so here we have it. I have a minimum of 63, quartile 1, 70.5, yada, yada, yada. And then we get to IQR. Again, IQR is quartile 3 minus quartile 1, right? Big number minus small number, equals your interquartile range. So that has a range of 7.5 degrees, right? Because all of these temperatures are in degrees. And then this SX is called standard deviation. And what standard deviation measures is variation or variability amongst a set. And for this particular video, we're not going to dwell on that. Not really sure why there was an emphasis on putting that in this chart. Personally, I don't think it's necessary with respect to box plots. So what are we going to do with this? Let's move on. Again, here are my values that I calculated by hand, and so you'll notice that the first box plot is already drawn, but let's just take a look at where this comes from. You have a minimum value of 63, and so what are we supposed to do? We're supposed to go right around where 63 is and make a mark. Then our quartile 1 is 70.5, so we go there and we make a mark. Quartile 3 is 78, we go there and make a mark. Double back for my median at 75, I make a mark, and then my maximum is at 82, so I make a mark. And then what did the instructions call for? The instructions said that after you got your quartile 1 and your quartile 3 to go ahead and make the box and then drop your median in there. So there's the box. Then from quartile 1, draw a line down to your min and draw a line up to your max. And although it's not that pretty as the one that was there originally, that is your box plot. So that's how that happened. The goal then, of course, would be for you in this line and in this line would be to build the appropriate box plots. And when you have the box plots side by side by side, now we can start to make some interesting comparisons amongst the three groups. We're going to hold off on dealing with these three items down at the bottom here. These pertain more specifically to graphing calculator applications, which we'll handle in another video, in an effort to keep this one short. So, take a moment to yourself and take all of the data that's here, and this is in millions of dollars, so 32 would actually be $32 million. Take this data, pump it into your calculator, run some one-variable stats, and get your 5-number summary and draw a box plot. So press pause now, and using your handout, use that to complete this. Press pause. Okay, so here's my data. Remember the units for my 5-number summary. This is $0.9 million. This is $1.5 million, so on and so forth. Here's my 5-number summary, and it's for N of 18 players. So there was 18 people there. So as far as, you know, we didn't ask for the mean, but if you added all of these up and divided by 18, that's how you would get the mean. So now here's my number line, and all I'm going to ask you to do is, again, press pause and make your own box plot, and then compare it to mine. So go ahead and press pause now. And there we have it. And what can we say about this set of data? If you were to look at the histogram, and again, in your calculator now, you would go to stat plot, right? Go to stat plot and look at both the histogram of this data and look at the box plot. When you look at the histogram, you'll see the skewness, which is very obvious, and that is also what is being demonstrated right here. A little bit of that skewness to the high side or skewness to the right. This is what my quick sketch of a histogram using a calculator looks like, and again, massive skew to the right. And what is the implications of that skewness? Well, your median, that 9.05, when I hit trace, that's somewhere in this bin right here. So our median is there. And where's the mean, right? Where's X bar or the mean going to get pulled? The mean's going to be somewhere to the right of the median. The mean is going to get pulled up due to this huge outlier way off to the right. So this is the point of the unit. Things are going to get big. This is going to be big implications here. So that's about it for this video. We'll see you soon. And hopefully your box plot knowledge is up to snuff.